Dear students, today we are going to start the second part of the previous lecture, that is single phase autotransformer. Here we are going to learn about the following topics. We have a general comparison of a single phase autotransformer with a two-winding transformer. Next we will learn about comparison of copper losses in between a single phase autotransformer and a two-winding transformer, and finally we will know what are the practical applications of a autotransformer. Okay, so without delaying, we will straight go to the comparison between a single phase autotransformer and a two-winding transformer. As you can see here, we have shown the comparison with the first column giving the basis of differences, and the second column is having autotransformer, and the third column is the conventional transformer. So first one is definition. A transformer having only one winding and a part of which acts as primary and another part acts as secondary is basically our autotransformer. Whereas in case of a conventional transformer, there are two distinct windings which are wound on the same core. Now definitely the number of windings for autotransformer, there is only a single winding, whereas in case of a conventional transformer there are two windings, namely primary and the secondary. You can see here the symbol of the autotransformer. This is the symbol of a autotransformer. This is showing the single winding, a part of which is acting as primary and part of that winding is acting as secondary. And this is showing you the magnetic coupling. Okay. And this is a conventional transformer. So there are two distinct winding and this is showing the magnetic coupling. Now the insulation, the primary and secondary winding are not electrically insulated. As you can see here, the primary and secondary windings are connected directly. That's why there is no insulation, there is direct electrical connection. But in case of a conventional transformer, you can see two windings are not electrically connected, so they are electrically insulated from each other. Now induction, in case of a autotransformer, it operates on the principle of self-induction, whereas in case of a two-winding transformer, it operates on the principle of mutual induction, because there are two distinct windings, and in the secondary the voltage is getting induced due to mutual induction. Okay, the size, as the number of turns are lesser and only single winding is there, definitely the size of autotransformer is small and the conventional transformer is large, considering the same kVA capacity. Okay. Now power transfer. In case of autotransformer, as there is direct electrical connection and magnetic coupling, so the power transfer takes place in two fashion, partly by conduction and partly by induction. But in case of a conventional transformer, the total power is getting transferred from primary to secondary by induction. And voltage regulation, as the length of winding is basically less in case of autotransformer, so we get a better voltage regulation. But in case of conventional transformer, though it is good, but it is not better than that of an autotransformer. Next, the winding material. As I have already learned that the length of winding is basically less for autotransformer, considering the same kVA capacity, the autotransformer is requiring less amount of winding material, whereas in the case of conventional transformer, the amount of winding material required is more. On the basis of circuit, what you can see, the primary and secondary winding circuits are connected both electrically and magnetically for a autotransformer, whereas in a conventional transformer, the connection between the primary and the secondary circuit is only magnetic. Okay, because there is a magnetic coupling, otherwise there is no direct electrical connection. Now the connection depends upon the tapping, means the load is being connected to a autotransformer at the secondary, that depends upon the tapping which is being selected at the secondary. But in case of a conventional transformer, the secondary, that is the whole secondary, is connected to the load. Now the cost of autotransformer is definitely less than that of a conventional transformer, and definitely the conventional transformer is costlier than a autotransformer of same rating. Losses, the losses for autotransformer is less, whereas for the conventional transformer it is at higher side, means it is more than that of a autotransformer. And in application, autotransformer is generally used as a starter in induction motor, as a voltage regulator in railways and laboratories, and the conventional transformer in power system is basically used for stepping up and stepping down the voltage at different segments or sections of the distribution and the transmission system. Okay, so this is all about the general comparison of autotransformer with a conventional transformer. Okay, in this slide we are going to learn about comparison of copper loss between two winding transformer and an autotransformer. We see that reduction in conductor material means reduction in conductor length. As we know that in case of an autotransformer of same rating, the amount of copper requirement is less than that of a conventional transformer. So reduction in conductor material, basically reduction in conductor length. Owing to this, the ohmic losses in the conductor is lower. As the length of the copper is getting reduced, so definitely the resistance offered by that conductor will be less, because we know R is proportional to L by A, or R is proportional to L. As the length is getting reduced, so the amount of resistance offered by that conductor is also lesser and the ohmic losses is also less. Therefore, an autotransformer has higher efficiency than a two-winding transformer of the same out. Means the efficiency of an autotransformer is higher as the losses are lower. Next, when a two-winding transformer is connected as an autotransformer, the current in different sections and voltages across them remain unchanged. Now, as you can see here, the same two-winding transformer is connected as an autotransformer. In this case, what is happening? The ohmic losses in both the cases are remaining the same. Therefore, losses when a same two-winding transformer is connected as an autotransformer, the losses in both the cases are remaining the same. Okay. So finally, the practical applications of autotransformer. So here we will talk about the most important applications. First one, compensating voltage drops by boosting supply voltage in distribution systems. So in distribution system, there may be certain parts where there is a dip in the voltage from the actual voltage level. Now with the help of autotransformer, we can inject the required voltage, which is basically dropping at a certain point, so that we can achieve the required amount of system voltage. Okay, these transformers are basically used as a boosting transformer. Okay, next, autotransformers with a number of tappings are generally used for starting induction motors, basically three-phase induction motors. We know that at the time of starting, if full voltage is applied, a huge amount of current is basically drawn by induction motors. So with the help of autotransformers, a reduced voltage can be applied to the induction motors so that lesser amount of current is being drawn from the system. Thus, autotransformers are very efficient devices for starting three-phase induction motors. Next, autotransformer is used as variac in laboratory or where continuous variable voltage over broad ranges are required. As you can see in physics lab, in circuit theory lab, in electrical machines lab, different electrical lab and electronics lab, and in several other labs where variable voltage is required from fixed AC supply, we basically use variac, which is nothing but a single phase autotransformer which receives a constant AC voltage, and with the help of which we can convert the constant AC voltage to a variable AC voltage as per our requirement within a wide range. Okay. Next, autotransformers are used to connect, basically interconnect two power systems which are at different levels. That may be 132 kV and 230 kV and several others. Okay, means we know that autotransformer can transform voltage from one level to another as a step up or step down autotransformer. So these are also used for interconnecting two power systems which are at different levels. So now we will go on to the next slide and we will learn about some important formulas for solving numericals. Two windings connected as an autotransformer will have greater volt ampere rating than when connected as a two winding transformer. As we know that if we connect a two winding transformer as an autotransformer, the rating of the autotransformer will be higher than that of the two winding transformer. Now, how these two ratings are related, that we can find with the help of the formula given here. The ratio of volt ampere means volt ampere rating of autotransformer by volt ampere rating of the two winding transformer is equal to small a suffix capital A by small a suffix capital A minus 1, where small a suffix capital A is nothing but the ratio of number of turns of the high voltage side of autotransformer by number of turns of low voltage side of autotransformer. So if a numerical is given with a two-winding transformer and its ratings, and we have to find out what will be the volt ampere rating of the autotransformer if we connect the two-winding transformer as the autotransformer, then directly from this formula we can find out the rating. Okay, next, in an autotransformer we know the transfer of electrical energy is by both conduction as well as induction. That means partially the power goes to secondary from primary by conduction process, and partially it goes to secondary from primary by induction process. Now with the given formulas here we can find what is the total volt amperes transformed from primary to secondary and what is the volt amperes conducted from primary to secondary. The volt ampere which is getting transferred by method of induction or inductively from primary to secondary is equal to 1 minus k suffix a into input volt amperes, and the amount of volt amperes which is getting conducted to the secondary from primary is equal to k suffix a into input volt amperes. Okay. Now here the input volt ampere corresponds to the volt ampere rating of the autotransformer which we have got by connecting the two-winding transformer as autotransformer, where this small a suffix a is equal to reciprocal of the small a suffix a, that is k suffix a is equal to number of turns of low voltage side of the autotransformer by number of turns of high voltage side of the autotransformer. So with the help of these formulas we can easily find out the amount of volt amperes getting inductively transferred from primary to secondary and directly conducted from primary to secondary. So finally there is a homework for all of you. You can attempt all these MCQ questions and check the answers at the YouTube channel EEMCQs. And if you have got any other queries, you can mail me to eemcqs@gmail.com. Thank you very much. Thanks for watching.